So we hit another snag when we start thinking about a problem like this. X plus 1 over x squared plus 4, x minus 3, okay? So it would be natural to assume that we would be able to write this as maybe a over x squared plus 4 plus b over x minus 3. Now the reason here is that x squared plus 4 doesn't factorise, okay? And subsequently, because it doesn't factorise, we can't write it as x plus 2, x minus 2, for example. So we can't expand it out into two brackets. So we've got to write it as a singular term, so it'd be a singular fraction. But there's going to be a problem here, because if you think about trying to go from the right-hand side to the left-hand side, what you would get is you would get a times x plus x minus 3 plus b times x squared plus 4, and somehow that's got to be equal to x plus 1. But in order to do that, because you'd have an x squared term, you'd need b to be 0. So in order to get rid of the x squared term, so what I'm saying here is that you'd have a lots of x minus 3 plus b lots of x squared plus 4 in the numerator. Don't worry about the denominator for the moment. But that would be what's in the numerator. Now to compare that with what you have in here, the x plus 1, the b would have to be 0 in order to get rid of that x squared term. And then a, well, there'd be no value of a that would work to make a times x minus 3 equal to x plus 1. And so this doesn't work. So this isn't quite right, okay? Now, in order to deal with that b times x squared plus 4, okay, in order to deal with that problem, because that's where the problem lies, we're going to have to write the numerator of this first fraction as ax plus some number b, and we're going to have that as c. Now the reason why we would do that is because now if I multiplied these together, I'd have ax plus b times x minus 3 plus c lots of x squared minus 4, and now c doesn't have to be 0 because I'm going to get an x squared from that term when I expand the brackets and an x squared there. So a combination there of a, b and c means I don't have to have c as 0. So that should now allow me to work through this problem. So when you have a factor in the denominator that is a quadratic that cannot be factorised, you must have ax plus b as its numerator. Okay? That's what we learn from here. So now we go about partial fractions as usual. We're going to have x plus 1. We're going to multiply both sides by the x squared plus 4x minus 3. And so we've got the ax plus b being multiplied by the x minus 3, because that's what it doesn't have, plus c lots of x squared plus 4. Now, we're going to let x be 3 to start off with. That will eliminate that bracket. So we're going to have 3 plus 1, so 4. That bracket is 0, so that goes. We've got 3 squared plus 4, so that's 13, so 13c. And so c is 4 over 13. Now, there is no value that I can substitute into this bracket to make it 0, okay? So from this point, I need to start choosing values of x. Now, because I've got ax, it makes sense to choose x as 0 to eliminate the a. So let x be 0. We're going to have 0 plus 1, so 1, is equal to, well, that's going to be 0. We're going to have b lots of minus 3, because x is 0, remember, so b lots of minus 3. And then we've got 4 lots of c. So 4 lots of c, which is 16 over 13. Okay, so then we can work out what b is. So 1 take away 16 over 13 divided by minus 3 is 1 over 13. So that's B. So now I've got B and C, and I've tried x is 3 and x is 0, so I just need to try another number now. So substitute in another number that's easy to work with, so let's choose x is 1. Doesn't matter what I choose. 1 plus 1 is 2. We're going to get A plus B, so we're going to have A plus B, which is 1 over 13, times 1 take away 3, so that's times by minus 2, plus C, so 4 over 13, times 1 plus 4, so that's times by 5. So let's simplify this, okay? So we're going to have 2 is equal to minus 2a, we're going to have minus 2 thirteenths, then we've got 20 over 13 there. So let's say 2, then add 2 thirteenths to both sides, and then take 20 over 13 from both sides, and that gets me 8 over 13 is equal to minus 2a, and so a would have to be minus 4 thirteenths. And so now you can write x plus 1 over x squared plus 4x minus 3, and that's equivalent to a, so minus 4 over 13x, plus b, so 1 over 13, all over x squared plus 4, plus c, which was 4 over 13, over x minus 3. Now obviously we don't want to finish writing it like that because that's absolutely terrible. So if I take that 13th down to the bottom, so we can have minus 4x plus 1 over 13 lots of x squared plus 4, plus 4 over 13 lots of x minus 3. Okay? And that is writing it in as nice a way as you possibly can. Okay? It looks absolutely horrible, but it's as nice as we can make it.